How to determine if a number is prime or composite. To determine if a number is prime or composite, there are three questions you have to ask. The first question is it one of the 13 primes, the first 13 primes that we need to remember? If you say yes, it's prime. If you say no, then you have to ask a second question. Does one of the divisibility rules work? Create your table to stay nice and organized and check all your rules. If one of them works and you find a factor of that number, then your number is composite. If you don't, then you have to try a third step. And your third step is to divide by the 13 main primes. Does one of them go in? If one of the primes works, it's composite. If none of them do at this point in time, you can assume the number is prime. We're going to check three numbers in this lesson. Let's start with 37. The first question is it one of the 13 primes? Write your primes down and check, is that one of the primes? If you notice, 37 is one of the primes. I put two extra primes in here so you would know that 43 and 47 are primes. They're often used as a trap because they are so close to the first 13 primes. So right now we can say 37 is prime, and we're done. Let's try the next one. Next, we're going to check if 93 is prime or composite. The first step is to ask, is it one of our 13 primes? It's not on our list, so we have to try our divisibility rules. Let's make a table to help us. I've got all of my digits that work with the divisibility rules, including 7 and 8, even though they don't have nice tricks. And it's time to see if any of them work. Now, for the number 2, we look, is the last digit even? Well, the last digit is 3, so no, it's not, which means 2 is not a factor of 93. Let's try 3. We're going to add up all our digits, and then we're going to divide that sum by 3 and see that we get nothing left over, which means we have found 3 is a factor of 93. Because one of our divisibility rules works, we can actually stop and know right now this is a composite number. I suggest you pause your video and fill in the rest of the chart and see if you find different numbers are also factors of 93. If you filled in your chart, you would find that none of them are factors of 93 other than 3. However, because 3 did work, it is a composite number. Let's go back to our chart. While 93 was not one of our 13 primes, we did get one of the divisibility rules because 3 went into it. So 93 is a composite number. Now let's try with our last number, 137. First, is 137 part of our first 13 primes? No, it's not. So we're going to have to go to question 2. Does our divisibility rules work? Create your chart, write down your rules, and start trying to see if this works. If you paused your video and actually tried, you should get something very similar to this. Let's look at our answers. We're going to find here that 2 is not a factor, 3 is not a factor, 4 is not a factor, 5 is not a factor, 6 is not a factor, 7 is not a factor, 8 is not a factor, 9 is not a factor, and 10 is not a factor. At this point, we have to keep working. Let's go back to our question is, does one of the divisibility rules work? And the answer was no, so we actually have to try all 13 of the main primes and see if one of them goes in. If one of them does, it's composite. If none of the first 13 primes go in, we're going to assume it's prime. The nice thing about the order we did our work in is we already know that 2 doesn't work because of our divisibility rules. 3 doesn't, 5 doesn't, 7 doesn't. Now, we could try counting up by 11, 11, 22, 33, and so on, but that's going to take a long time. It's actually a lot faster to simply try multiplying. 11 times, I don't know, let's try 13. Maybe this will work. 1 times 3 is 3. 3 times 1 is 3. Put a placeholder. 1 times 1, 1 times 1, 3, 4, 1. That was a little bit too much. So if I took 11 off, 132, that's now too little. 11 does not go into 137. Let's take a guess with 13. Maybe I think this will go in 9 times. 9 times 3 is 27. 9 times 1 is 9, plus 2 is 11. Not enough. I can then just add in a 13, and I can see another 13 would be too big. Try checking the rest of your answers to see if any of those is a factor. If you find one number that's pretty close, like here I found 17 times 8 was 136. For the next prime, try one less. It's times 7, times 6, times 5. I'm going to assume times 4 is going to get me close because there's a pattern here. 124. Not quite enough. We'll add in another 31 and see that it's way too much. I'm going to try times 3 here. 393, not enough. Let's add another one. We can see if I add 30 more, it'll be over 150. Let's try 3 again because it was too short. 123. So we have found none of our first 13 primes works. Going back to our statement, no, none of them work. That means our number is most likely prime.